Hey guys, this is Taylor, and today we'll be learning about a concept which is Sieve of Eratosthenes. So this concept we'll be learning today, what it is and how it helps optimize prime calculations and all. So here I have opened one question from the Leetcode, and in that question, what we have to do. So let's see, okay, we have some number given n equal to let's say 5. So I have to tell from 0, 1, 2, 3, 4, 5, from 0 to let's say 5, how many numbers are prime. So I can pick these three numbers are prime. So my answer will be 3. Okay. So this is the question about. So I have written some basic code here, some function which basically checks the prime in square root of n times. So I am running loop till square root of n, and here basically I am having a loop of n. Basically, I am just iterating from 0 to that number, and I am checking whether that number is prime or not. If that number is prime, I am incrementing the count. So I hope everyone, this is very easy concept. I don't need to go in very deep for this. So just to give you some idea why this code will not work. Because so my highest constraint is 10 to the power 6, 5 into 10 to the power 6. And if I try to calculate that much iterations, I'm getting time limit exceeded here. So we need to do something. We need to do some optimization here, right? So what optimization I can do? Let's see. So we have some method of Sieve of Eratosthenes. So this method help us to do prime calculation very fast, very quickly. So I have written something here, some range, let's say. So let's consider that we have range from 0 to 20, let's say, for just for an example, just for understanding purpose. So I will definitely go and mark this as zero, because I know 0 and 1 are not the prime numbers. Now I start from here. So we will get the idea. So let's talk about the intuition first. So I know 2 is prime number, yes. 3 is prime number here. But I know 4 is not a prime number. Why I know this? Because it is divisible by 4, it is divisible by 1, that is fine. But it is divisible by some other number in that range. That is that is the intuition behind this Sieve of Eratosthenes, whatever that name is. So how I will be solving this. So I will not be going like I in the traditional prime number find. What I was doing is I will pick some number, let's say this 14. I will try to go till square root of 14. Let's say square root comes here for an example. I'm going till here, every number, and I'm checking whether those numbers can divide this 14 or not. That's what I was doing till now. But I can come up with some basically optimization here. Instead of going from picking that number and going backwards and then again coming forward, instead of doing all these things, what I can do, I can keep calculating my prime numbers from front itself. So let's see what I'm talking. So this is a very interesting question, interesting method as well. So let's say I'm here, okay. I have to start from here because 0 and 1 are non-prime. I know one thing. So I will start from 2. Now, what I need to do, I will start from 2, let's say, and I will multiply 2 into 2. I get 4. So I know this 2 can divide 4, right? So I will be going and I will marking this as 0. Okay. Now I will be multiplying it with 3. What I'm getting? 6. I will put a 0 here. Similarly, I can put a 0 in front of this, everywhere. Okay, nice. Now this 2 into 4, 2 into 5, 6, 7, 8, 9, 10. Let's consider that I have done till here. Now so this thing is fine. This thing is fine. Now I will come here in the next position. I will check whether this is 1 or not. If this is 1, that means that 3 can't be divided any of the numbers from the previous. So I know that 3 is a prime number. So okay, that is fine. But what I need to do in that case, I need to check for its divisibility. So I will be going from 3 into not 3 into 1. I will be going from 3 into 2. Okay. So 3 into 2 is 6. Okay. 3 into 3 is 9. Okay. I can move this to 0. 3 into 4 is 12. Okay, this is already 0, nothing to do. 3 into 5 is 15. I can move it to 0. 3 into 6 is 18. So 18 is already 0, not an issue. Now 3 into 7 I won't be doing because that is out of range. Okay, the same thing I have to do for 4, 5, 6, 7, 8, everyone. So 4 I will not be doing this because this 4 is already 0, right? So whatever number divisible by 4, let's say 4 can divide 8, 4 can divide 12, 4 can divide 16. If 4 can divide, then 2 can also divide, right? Because 2 is dividing 4 and 4 is dividing 12. That means 2 can directly divide 12, right? So I will not be doing it for 0. I mean for this 4. So I will be doing it for 5 because here I am having 1. And what does it mean? That 5 is a prime number. So let's start. 5 into 2 equal to 10, which is already marked as 0. 5 into 3 equal to 15, which is already marked as 0. 5 into 4 is 20, which is already marked as 0. Okay, no issue. So the next number I have to do is 7. Okay, 7 into 2 is 14, which is marked as 0. 7 into 3 is 21. So not a problem. Now 8, 9, 10, 11. Okay, I have to do for 11. So 11 into 2 is 22, which is out of this range. So I don't have to do it for 11. So, uh, I hope you guys got it how we are calculating. So if we have to calculate for 10 to the power 5 now, we can simply calculate it. So there is this approach is fine, but I have some more optimization in this. So let's try to first write pseudocode of it and then we will try to optimize it more. So let's see, let me write the code. What I have to do for I n, so I will have to define the prime array of 0, 0, sorry, 1, 1, 1, it should be 1, 1, 1, 1, 1. How many times? It should be 10 to the power 6 times. 5 into 10 to the power 6. I will type plus 1 as well because these are indices. So indexes start from 0, 1, 2 till 5 into 10 to the power 6. Okay. So that's why I'm writing it's plus 1 here. So I will define the array of this size and what I have to do here. So what we have done, we checked whether that number is 0. If that is 0, I have nothing to do. If that is 1, then I have to do some stuff. So before that, I have to define that prime of 0, which means that 0 is prime or not and 1 is prime or not. So prime of 0 and prime of 1 is false or 0, I can say, right? Fine. Now the next thing is for I in range, I will be going from 2 to 5 into 10 to the power 6 plus 1. Okay. I'll be going like this and I will be what I have to do. I have to basically check if prime of I equal to 0. In that case, I am safe. I am safe to skip that part. So I will write a continue here. Okay. And otherwise, what I need to do? I need to mark all the numbers which are divisible by current number, right? So what I will be doing is for j in range. This J in range syntax is nothing but the for loop only. Some like it's something Pythonic way. We should write ideally some pseudocode independent of language. So from where I have to go? I have to start from I, okay, and I have to go till 5 into 10 to the power 6 plus 1, okay, and whatever number I can divide, I will start dividing it. So if I can start from into 2 because we were starting into 2, right? We were starting from 2 multiply by 2. So if j can if j modulo I equal to 0, then I can say that prime of j is not a prime number. Yes. So that way, if I start from here to, I will be making that 0, 0, 0, 0, 0. Okay. So I hope you got it, what we are doing in this part. So let's again come on this part and see whether we can still optimize some part or not. So the first thing that I can see is basically in prime, I remember one thing that in prime I was going from, let's say if I have to determine whether n is prime or not, I was going from 0 to square root of n, right? Because I have basically mathematical proven the proof. So proof is simple. So for proof, what we have to do? So let's say my range is 20, right? And if I determine the square root of 20, so it will come from like 4 point something something will come, right? So why I can only run till 4? Because if you know 4 into 4 is 16. Okay, and if you write 5 into 5, that will be 25, and this 25 will go out of this 20 range. That's why this square root method will definitely work. So I will just take this integer part of a square root and I increment plus 1 there. So that, I hope you got the intuition why we are writing. So that's the same thing I can write here as well. So instead of going till this part, till this long part, I can write something like square root of 5 into 10 to the power 6 plus 1. Yes, I can definitely write something like this. Okay, the next thing, next optimization. So here, see, 2 into 2 equal to 4, 2 into 3 equal to 6. Here I like what all numbers I changed here. This part, 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 this part. Okay. Now when I reached at 3 and I started again from 3 into 2, I went here, and this was already marked as 0. So I know one thing that okay, let's move again. So here I have written something like 5 into 2, and I come here and I can see that this is already marked. 5 into 3, it's already marked. 15 was already marked by 3, right? So the idea behind the optimization is, so if I'm writing from 2 into 3 and I'm again writing 3 into 2 here, I can see that 3 into 2 exists here, right? Similarly, if I write 5 into 2, I can see that 2 into 5 exists here. If I write 5 into 3, I can see that 3 into 5 exists here. I hope you got it right. So what I can do, instead of starting from 2, instead of starting from 2, 3, 4 here, from 2 here, what I can do, I can start from that number into number, because that number is proof that it can't be reached from any of the previous numbers, so I can start from that I into I. Okay, so what I can do here is, okay, instead of going from 2 into I can go from I into I. So that is again another optimization, and that way I think we can definitely count the sieve of primes. Let's try to write code for it and see whether that is working fine or not. So I will write prime equal to 1 initially, and I will write something like 10 to the power 5 plus 1. Okay, because we have indexes from 0 to 10 to the power 6. Sorry, 10 to the power 6. And it should be 5 into 10 to the power 6 more specifically. Fine. So I know one thing for sure, that what we had done here. So prime of 0 and prime of 1 is 0. So I will write same thing here. Prime of 0 equal to prime of 1 equal to 0. Now what I need to do, I need to start from 2 itself, because I know 0, 1 are non-prime number. For I in range 2 to till when I have to go square root of n. So I should write something like this: max range equal to this number, and that will be, I think, more perfect, more easy to write. Okay. Now what I need to do next? I need to check whether that number is prime or not. So if prime of I equal to 0, then I can definitely skip that part, because that number is already non-prime number. So all the multiples must be not prime. Okay, so else what I need to do for j in range, what I need to do, I have to go from I into y till when? I have to go till max range, right? And what I need to do? I need to basically check if j can divide the I, if I can divide the j. Wait. Yeah, so there is one silly mistake that we did. So we don't have to write any if condition here. We can directly define that as 0. So let me remove this part. This should not be there. I can directly tell that, okay, if I am inside this loop and I can, that means that I can divide that number. So prime of j would be equal to 0. Okay, so let me write the same here. Prime of j will be equal to 0, and that would be fine. Okay, yeah, so we have to write the I here because we have to jump from the ith step. So what we are doing here is 3 into 3 equal to 9, 3 into 4 equal to 9, 3 into 5 equal to 9. Every time we are jumping with that step, 9 difference, 9 difference, 9 difference, right? So that's why I'm writing, I will be starting from here. I have to go till here and I am jumping with the II steps. Okay, so I think that is fine. Now let's try to remove this part and let's see whether we got some optimization or not. So instead of using this, I will be using this array and I will be just checking that number is prime or not. Let's see. Let's see whether it is working fine or not. Okay, this time it worked, and the time is very less, 155 milliseconds. And if we submit this, this will definitely work fine because this sieve of prime number is very efficient method to calculate the prime numbers. And yeah, we got the accepted answer. So I hope you got the intuition behind this problem. And if you guys learned something new, just give a thumbs up so that I can know that you guys have learned something. And if you don't, if you have some doubt, just mention in in comment section. I will definitely try to reach and explain as soon as possible. Thank you very much, guys, for watching this video.